Plenum rated. The champion of local networks, unshielded twisted pair. Unshielded twisted pair, commonly known as UTP, is the undisputed king of local area networks. If you look at the back of your computer, the cable connecting you to the wall or the router is almost certainly a UTP cable. It has become the most common networking cable in the world because it strikes a perfect balance. It is inexpensive to produce, incredibly easy to install, and more than capable of handling high-speed data for the vast majority of indoor environments. The anatomy of simplicity. As the name suggests, UTP consists of several pairs of copper wires. In a standard network cable, there are 4 pairs for a total of 8 individual wires. Unlike its armored, sibling, shielded twisted pair, UTP has no internal metallic foil or braided mesh. It relies entirely on its physical construction and the math of the twists to protect the data signal. The cable is built in 3 main layers. At the very center of each of the 8 wires is a thin strand of copper that carries the electrical pulses representing your data. Surrounding that copper is a layer of color-coded plastic insulation. These colors, orange, green, blue, and brown, are essential because they help technicians follow the industry-standard wiring maps. Finally, the entire bundle is encased in a simple PVC jacket. This provides basic protection against physical wear and tear, but it offers no protection against moisture or heavy electrical noise. The science of the twist. You might wonder, if there is no metal shield to block interference, how does the data stay clean? The secret lies in a concept called cancellation. Whenever electricity flows through a wire, it creates a small electromagnetic field. If 2 wires run parallel and close together, the field from one can bleed into the other, creating noise that scrambles the data. This is known as crosstalk. However, by twisting the 2 wires of a pair together, the magnetic fields are constantly flipping their orientation. This causes the interference from the 2 wires to effectively cancel each other out. Furthermore, in high-quality UTP, different pairs within the same cable are twisted at slightly different rates. This prevents the pairs from syncing up their interference, allowing the cable to carry high-speed data for up to 100 meters without needing a bulky, expensive metal shield. Why professionals choose UTP? There are 3 main reasons why UTP is the go-to choice for 90% of all networking jobs. First is cost. Because it lacks expensive metal foil or braided shielding, UTP is significantly cheaper to manufacture. When you are cabling an entire office building or a school with miles of wire, these savings add up to thousands of dollars. Second is ease of installation. UTP is thin and very flexible. It can be easily pulled through tight wall cavities, bent around sharp corners, and stuffed into crowded server racks. Shielded cables, by comparison, are stiff and much harder to fish through walls. Third is ease of termination. Putting an RJ45 plug on a UTP cable is a quick and straightforward process. You don't have to worry about draining a metal shield or using specialized, expensive grounded connectors. A technician can terminate dozens of UTP cables in the time it takes to do just a few shielded ones. The limitations of UTP. While UTP is excellent for most situations, it isn't invincible. Because it lacks a shield, it is vulnerable to electromagnetic interference, or EMI if you run a UTP cable too close to a high-voltage power line, a large electric motor like an elevator, or even a bundle of fluorescent light ballasts. The electrical noise can overpower the cancellation provided by the twists. In these high-interference environments, the connection will drop or slow down significantly. In those cases, a technician must stop using UTP and switch to a shielded or fiber optic cable.